polynomial and rational inequalities. I'm going to draw two random graphs, one polynomial, which is bouncing, crossing, and I'm going to draw one rational. So let's just say you have an x-intercept at -4, and we're going up, and you have an x-intercept at -1, and I'm going to bounce, and I'm going to cross, and I'm just drawing some random graph here. Pause on your own, wherever you'd like. If I want to know where is this random function greater than or equal to 0, f of x, same thing as y. So what I'm asking you is, where is this graph above the x-axis? Where is the graph above the x-axis? Well, you'll notice that at the x-intercept at -4, this graph is above the x-axis, and then it continues to be above the x-axis because at -4 we bounce. And at the x-intercept of -1, that's when it switches. It goes from above the x-axis to below. And then it switches from below the x-axis to above at the x-intercept of +4. So what really matters here are the x-intercepts. The x-intercepts are where we're going to switch from potentially greater than 0 for y or less than 0 for y. So for this particular problem, I am greater than or equal to 0 from -4 to 1, and it's or equal to, sorry, -1, in union with, I believe that's +4, to infinity. And remember, infinity is always a parenthesis. So the x-intercepts are super important. Well, what happens when you have a rational function and we throw some, in there? Some vertical asymptotes. So let's throw in a vertical asymptote at x equals -2. And let's throw in another vertical asymptote at, how about 4? Just making this up. And then let's throw in a horizontal asymptote somewhere. Thing that you need to remember with horizontal asymptotes, they never go through the quote-unquote middle. Horizontal asymptotes describe end behavior. Well, guess what? Between -2 and 4, that's not end behavior. We're talking about when x approaches positive infinity, when x approaches negative infinity. So you should not be drawing your horizontal asymptotes in between the asymptotes. And I just randomly drew this in at y equals +3, excuse me. Okay, again, what really matters is what's happening for the x-intercepts, or in this case, the vertical asymptotes. So let's just say I draw in a branch here, and then I draw in some random x-intercept at 1, and it bounces. I'm totally making this up. It should be a curve. And then let's say that you are here, okay? From x is -infinity all the way to -2, the graph is above. Time out. I should have told you, let's look for greater than 0 again. My apologies. Let's look for greater than 0 or equal to. So I am above the x-axis from -infinity up to -2, and I'm still above the x-axis from -2 down to 1. So this graph is greater than 0 when x is -infinity all the way up to +1. Or equal to, it's going to be included. But at +1, I just messed up from +1, it continues to be above the x-axis. So it continues to be above the x-axis until we hit this vertical asymptote, which is at 4. So this is not correct. It should have been -infinity to 4. And this is not right either, but I purposely messed this one up. Asymptote, never included. So something's going on here though. I included 4. Sorry, that's -2. Wow. I included -2, but I shouldn't have. -2 is an asymptote. So this should be -infinity to -2, parenthesis, in union with -2 to +4, parenthesis. Even though this says or equal to, it doesn't matter. So infinity always an parenthesis, and same with asymptotes. So infinity, -infinity are always parentheses. They're never included. So never brackets. And VA, vertical asymptotes are always parentheses as well. Little, whatever you call those little thingies, never included as well. Okay, so we're gonna take that with us into polynomials, as well as end behavior, etc. So let's say I give you the f of x, and I want to know that I'm going to tell you the f of x is, I don't know, how about x minus 4 quantity squared times the quantity 2x minus 1 times the quantity x plus 3 squared. Let me try and focus that a little bit for you. Okay, so I want to know, where is this less than or equal to 0? So we're going to find what we call our critical values. Well, in the sections leading up to this, you would tell me that you had an x-intercept at 4, 0, multiplicity, I'm frozen. Sorry about that, I was frozen. X minus 4 squared, the x-intercept is at 4, 0. Multiplicity is 2, this bounces. X-intercept is at 1/2, 0. Multiplicity is 1, this is a cross. And x-intercept at -3, 0. Multiplicity is 2, that is also a bounce. So you were doing this in the previous section. If you were to multiply this out, your leading coefficient would be 2. So we would have x squared times 2x times x squared, which I believe is 2x to the 5th. This would be my lead term. This is going to be down, up, and behavior. I don't want to draw the whole graph. I don't need the whole graph. All I need is my x-axis. So I'm just going to draw in an x-axis, so to speak, i.e. a number line. You need a number line for all of these inequalities. Every inequality needs a number line. So I'm going to plot, I've got, and I don't care where you put it. Let's see, we have 4, 1/2, -3. This is good enough for me. Or equal to. Okay. You could, if you wanted to, plug in a number to every one of those intervals and see if the answer is positive or negative. Nope. You know your end behavior. If this were my x-axis, I would start with 4 and I would go up, positive. I would look at -3, that end would go down, that's negative. Some people like to put their negative sign below the number line. I don't do that, but if it's confusing to you, I'm just indicating that from negative infinity to -3, the y values are negative. Well, guess what? At -3, we bounce. So if the y values were negative to the left, they're going to stay negative to the right. At 1/2, we cross. So we switch from being negative to being positive. And at 4, we bounce. So guess what? That matches. So if you were to graph this, you'd have -3, 1/2, 4. Your end behavior would be down, up. We would bounce at -3, so we would stay negative. At 1/2, we would cross and then bounce. I just took the y-axis out of it. You don't need a y-axis on your number line. If you want to graph this whole thing, feel free, but it's really not something you should have to do. Less than or equal to. Negative infinity. -3 is included, so I don't need a separate interval. So I'm going to take that all the way up to 1/2. And there's my answer. This graph is below the x-axis. The y values are negative all the way pa-ching till you get to 1/2. Do not write a separate interval for -3. If the problem said less than 0, if the problem said less than, meaning not or equal to, then your interval would be negative infinity to -3 parenthesis in union with 3 to 1/2. That would be the correct answer if it were not equal to. This is not okay. It's not okay to write negative infinity to 1/2, x not equal to, that should be a negative, x not equal to -3. This is not, no, that's no bueno. All right, I'm going to look at a couple that tend to cause voodoo math, as Mr. Perryman and I like to call it. X to the 4th less than 9x squared. The degree is 4. This is what I'm going to show you now is incorrect, but I'm going to explain. This is what I see a lot. Divide both sides by x squared, and then you get x squared is less than 9, x equals plus or minus 3. No, no, no. The degree is 4. If you recall, degree tells you how many answers you should get. 4 answers, maybe real, maybe imaginary, but there are 4. When you divide by a variable, you change the degree. You changed the degree from 4 to 2, which means you just took out 2 solutions. Never divide by a variable. No, no, no. No divide by variable. You change the degree. And in this particular problem, you're going to change the x-intercepts, which is going to change your intervals. You want it to be equal to, or in this case, less than or equal to, or greater than or equal to, or whatever it is. You want to use the zero product property. You have to set it equal to 0, less than 0, greater than 0, whatever. Factor. You factor this. GCF is x squared, difference 2 squares. I have 4 critical values. I have 4 x-intercepts. This is x equals 0, bounce. This is x equals -3, so I really should be writing it as an ordered pair. Cross, +3, cross. Okay. X to the 4th, positive 1x to the fourth, this is an up. Not or equal to, open circle. You need a number line. It doesn't have to be a perfect number line. That says 3, not very clear. Okay, up. Up. At -3, we are crossing. So we are switching from positive to negative. I think that might be confusing for some of you if I put the negative sign on top. At 0, we bounce. We stay negative. And we go back up. Okay, less than. I want the negative intervals. That's here and here. Parenthesis, -3 to 0 in union with 0 to 3. You need the union symbol. This is your proper interval. And I'm sorry to do this to you, but I do need to go back. I didn't shade up here. What do we want? Less than. So that's here. That's here. I did not shade the number line. Sorry about that. Okay, rational inequalities. So these are polynomials. The rational inequalities are the ones that are way more fun. I think they're way more fun, but that's because I'm a math teacher. If I didn't think it was fun, I don't think I'd be a math teacher. Okay. Let's see here. Let's do. I'm trying to give myself a little bit more room here so I can save some paper. All right, here we go. Let's look at 5 over x minus 3 greater than or equal to 3 over x plus 1. That's a 3. My 3's don't come out very well. Your cross multiplying days are over. This is why other teachers stress to you not to cross multiply, because when it's an inequality symbol, things get messed up. Multiply through, no, sorry, let's subtract first. So let's make this 5 over x minus 3 minus 3 over x plus 1 is greater than or equal to 0. When you cross multiply, you get rid of the denominator, and that's a major problem. When you cross multiply, you get rid of the denominator. Let me just show you up to the side. You'll say, oh, 5x plus 1 greater than or equal to 3 x minus 3. I know that's super small. What happened to the denominator? You just eliminated it. This has vertical asymptotes. This has 2 vertical asymptotes. One at x equals 3, one at x equals -1. When you cross multiply, where'd they go? No cross multiplying. Common denominator, x minus 3, x plus 1. Multiply through by the, not multiply, find the common denominator. Common denominator is x minus 3, x plus 1. Okay, so pause it, figure it all out. Get 2x plus 14 over x minus 3, x plus 1. Do not multiply that out. Do not multiply that out. You need to know your vertical asymptotes. So if we were to graph this, we look for these, what we call critical values. The critical values, x-intercepts, asymptotes. Critical values are x-intercepts and vertical asymptotes. Okay, we have -7, 0 for an x-intercept, and it's a cross. We have x equals 3. We have x equals -1. Multiplicity is odd, so we're going to go in the opposite direction, odd opposite. So these are the values that need to go on my number line. -7, -1, and +3. Let's see, -7, -1, 3. Or equal to, okay, that means closed circles. No, it doesn't. Vertical asymptotes are always parentheses, which are the equivalent of open circles. Open circle at 3, open circle at -1, always. I don't care that this says or equal to, you can never include an asymptote. If x is 3, 0 in the denominator, never. It's got to be an open circle. -7 as an asymptote, that can be included. Sorry, as an intercept. -7 as an intercept, no problem. That can be included. Okay, so then you get to here and there's no end behavior. I mean, there is, but unless you graph it, you're not really sure. When you get to here, plug in a value to determine if the y value is positive or negative. So this is what I do. I know that at -7, I'm going to cross. So I'm going to switch from positive to negative and vice versa. I know that at -1 and +3, I'm also going to be opposites. So I'm going to switch from positive to negative. I just don't know where to start. Well, sure you do. Plug in some ridiculous number. Plug in 1,000,000. Plug in 16,000. Plug in whatever, a gajillion, quadrillion. That's not really a number, but that's okay. If I plug in a really large number for x, the numerator is positive, the denominator is negative. 2 times quadrillion, bazillion plus 14 is positive. Quadrillion, bazillion, oh, it's positive. I made a mistake. Quadrillion, bazillion minus 3 is positive. Quadrillion, bazillion plus 1 is positive. This whole thing is positive. Plug in whatever you want. I don't care what the actual value is. I just care if it's positive or negative. Everything now is crossing or opposite. So it switches from positive to negative to positive to negative. Check another number if you want. Plug in 0, you should get a negative. Plug in negative quadrillion, you should get a negative. Greater than, I want here, and I want here. My answer is -7 included with -1, not included, in union with 3, not included, to infinity. And again, -1 and -3 are open, I keep saying negative, sorry. -1, +3 are open circles because they are asymptotes. And even though this says or equal to, doesn't matter. Asymptotes are always open circles, always parentheses. How did I get that the here was positive? I plugged in a number, got a positive value. Plug in 0, you should get negative, and you do. You can, if you want to, plug in numbers that fit in those intervals, but it's not worth your time. Okay, I'm gonna do 2 more. Obviously, you don't have to watch the video if you don't want to. Let's do another one where we can practice. Let me focus this. Where we can practice with the denominators. Let's do x plus 12 over x less than 7. I'm going to stick with the or equal to, just so you get some practice with the asymptotes, etc. Okay. Don't lose this x. You're going to want to multiply through by x, and you're going to lose the fact that x equals 0 is an asymptote. X equals 0 is a critical value. It's a vertical asymptote, which means it's going to be an open circle and it's going to be parentheses. Okay, so the common denominator is x. Let me just write x plus 12 over x minus 7 is less than 0. X squared plus 12 minus 7x all over x is less than or equal to 0. This factors as x minus 4, x minus 3 all over x. So you have x-intercepts, 4, 0, 3, 0. These are both cross. And then we have the vertical asymptote above at x equals 0. I got x squared plus 12 minus 7x because I found the common denominator. The common denominator between 1x and 1 is x. So the critical thing to remember is not to lose a critical value. Haha. Are we at 0, 3, and 4? The x-intercepts at 4 and 3 are included. X-intercepts are included. The asymptote, always an open circle, not included. Okay, I'm going to plug in quadrillion thousand. Quadrillion thousand minus 4 is positive. Quadrillion thousand minus 3 is positive. Quadrillion thousand is positive. Positive times a positive divided by a positive is a positive. I don't care what the value is. Everything is a cross, so I switch from positive to negative to positive to negative. Less than or equal to, I want the negative values. Negative infinity to 0 in union with 3 to 4. Okay, I'm going to give you one more. I'm going to give it to you in factored form, and we're going to do one of those really funky ones that has, 17 critical values. Let's say I give you x plus 3 squared times 2x minus 5 to the 4th. I keep using colors that don't work. This is, let's do x minus 6 all over, how about x plus 3, x minus 1 squared, and I don't know, x plus 5 cubed, and let's do less than or equal to 0. First thing you need to do, well, push pause, write it down. First thing that you're going to want to do is find your critical values, but here's what's going on right there. It's a whole. When you reduce this, it's a whole. So let's watch what happens. I'll explain that in a second. I was going to rewrite all this. Cool. It's an x-intercept all of a sudden. I reduced x plus 3 squared over x plus 3 reduces. So now it appears to be an x-intercept, and it is not an x-intercept. This is now a whole on the x-axis, not included. It's a whole on the x-axis. It is not included. So let me push that aside. I'm going to have 5 halves 0. Multiplicity is 4. This is going to be a bounce. 6, 0. Multiplicity is odd. This is going to be a cross. And then I'm just going to put -3, 0, and I'm going to remind myself that it's a whole. Vertical asymptotes, x equals 1. Degree is 2. So this means we're going to go the same direction. So it's the equivalent of bouncing. X equals -5. It is odd. This is the equivalent of opposite. Here we go. Okay, we have 1, -5. Okay, we have -5, -3, 1, 5 halves, and 6. Or equal to. So the x-intercepts are included. Those are closed circles. So 5 halves included, 6 included. Whole, not included, open. Asymptotes, not included, open. Okay. Ugh, you know, plugging in 0 might actually be easiest, but here we go. So you plug in a bazillion. That is positive, 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 positive. Plug in a big number, you end up getting positive. So here we go. At 6, I cross. So I'm going to switch from positive to negative. At 5 halves, I bounce. So I'm going to stay negative. At 1, same, stay negative. Same direction, so if it's negative, it stays negative. If it's positive, it stays positive. -3 is a whole, but the multiplicity of the whole is 1. The multiplicity of the whole is 1, so I'm going to cross. And at -5, opposite, cross, opposite, same thing. Less than or equal to, that's a lot. This graph is pretty much all below the x-axis. Parenthesis, -infinity to -5. In union with -3 to 1. In union with 1 to 6. I can count this as one interval from 1 to 6 because 5 halves is included. So do not write that as 2 separate intervals. It's a lot. I probably made a mistake. Let me know.